Okay, 8.5a, preparing for calculus. All right, I'm not going to spend a whole ton of time on this lesson. There are a stinking, holy cow, 20 examples to go through here, and a lot of it has to do with what are called derivatives. And if you've not heard of a derivative, when you get into calculus, you will be working with derivatives if you move that far. And a derivative is basically, well, let's say that we have a parabola and we have a point. And we want to know what the slope of the line that goes through that point is. Okay, there's only one slope that will go through that point that is tangent to this parabola. Okay, tangent meaning it intersects this parabola at one point, which means the line going through here will be only one line. There's only one line in the whole universe that will go through that point and still be tangent. Yeah, we can draw a line that does that goes through two parts of that parabola, but it's not tangent to the parabola. All right, so the slope of this line that is tangent to the parabola is called a derivative. So the derivative is the slope. And we've been doing things like this. The derivative uses a little apostrophe up there to show that you're finding the derivative there. Okay? So they're pretty much just going through basic math. Example 3, they're telling you what the slope of a tangent line. Calculus can be used to find the slope of the tangent of a curve, which is the derivative. The slope of the tangent to the curve, y equals f of x at x equals a, is f of, the derivative of a. If the derivative of x is 4x cubed minus 3x squared plus 1, find the slope of the tangent at x equals 2. So all you're doing is plugging 2 into the 4x cubed minus 3x squared plus 1, okay, and finding an answer, and you're getting 21. So that is the slope of the tangent at that curve. Another huge part of calculus, at least at the beginning of calculus, is example 5, the difference quotient. We have done that, that formula in earlier lessons where it looks like this: f of x plus h minus f of x all over h, where x cannot be 0. And then it says what is, or if f of x equals 3x plus 2, you're supposed to find this here. Okay? So if f of x equals 3x plus 2. So what you're going to be doing there is, for, let's say, I'm looking at b in example 5. We're just going to put 3 times x plus h plus 2. Okay. So see what happened there. Okay, we've got 3x plus 2 here. And this here says wherever you see an x, we're going to replace it with x plus h. So that's all I did. Minus f of x. Well, what is f of x? F of x is 3x plus 2. Don't forget your parentheses. Over h. Okay, then you're going to just, distribute. Okay, and those go away because we have 3x minus, we have 2 minus, and we have 3h over h goes away, and we just have 3. Okay, so that's pretty much all you're doing there with the difference quotient. You're solving equations, you're rewriting radicals, not doing anything that we haven't already done. So just look through there, and we will you will have homework assignments over this stuff, but The stuff that is new with the derivatives and stuff will not be on the test or the final, but some of the other stuff will show up on tests and finals just because it's stuff we've already done. It's just old stuff that they're just kind of reviewing, preparing you for calculus. So nothing really nasty, but just kind of gives you an idea of what's going on. Let's look at example 16 really quick. We have that there. Okay, what are they asking? Sometimes a derivative contains negative exponents, and simplification requires all exponents to be positive. So they're just saying write this as all positive exponents. So remember what negative exponent means. It means that whatever's before it, whatever's after it, is in the wrong place. So we have an x and a 4 that were in the wrong place. They were on top here as numerators, and they shouldn't be. That negative says, nope, they're not right. This one here says that that is where it should go. Now, one of the things that's important here is it doesn't mean everything in front of the negative is in the wrong place. It just says that the first term, or the first part here and this here, whatever's directly to the left and right, go in their opposite position. If this were like that, that would mean that the negative 3, it does include the 2. But since there's not parentheses around it, it does not include the 2. And that was the same with up here. It did not include the 3. That 3, it stayed right where it was. Didn't move it at all. Okay, so example 17, using logarithmic properties. We're reducing fractions, simplifying expressions, solving equations. A lot of review there for you to go over. So please take time to review this stuff and to go over it, but it doesn't do me any good or you any good for me to just ramble on about how to do this when you can just look at these and get it on your own without any hassle. So anyway, that's 8.5. You have any questions going over 8.5, let me know. I'm happy to help you. But I don't really think you're going to have too much trouble.